Hey, ladies and gentlemen, today we're going to talk about acids and bases. They're everywhere. They're in your food, in your house, even in you. So acids and bases. What is an acid? An acid is a solution that has an excess of hydrogen, positive hydrogen ions. So remember, hydrogen has one electron, one proton. So if a hydrogen atom loses its electron, it becomes basically a positive hydrogen ion, and that is what makes up acids. Acids are made up of positive hydrogen ions, hydrogen atoms that have one more proton than electron. The Latin word for acidus means sharp or sour. Okay? And the more positive hydrogen ions you have in a solution, the more acidic the solution is, the stronger it is. So again, an acid is when you have positive hydrogen ions in a solution. The more you have, the more acidic it is. And acid stands for sharp or sour. So what are some properties of an acid? Well, acids tend to taste sour. Think of like a lemon. A lemon is acid. They conduct electricity pretty well. Get rid of this thing, hang on. They are corrosive, which means they can break down certain substances. Many acids corrode fabric, skin, paper. Okay? Some acids react very strongly with metals and will actually eat away at metals. And guys, acids will turn blue litmus paper. So if you have litmus paper and it's blue, they will turn the paper red. Guys, litmus paper is a type of paper that has been chemically treated to test to see if something is an acid or an alkali, which is also known as a base. If you have blue litmus paper, it will turn red when you have an acid. So again, the thing to remember, acids taste sour, they conduct electricity, they're very corrosive, they eat away at things, they can eat away at metals, and they turn blue litmus paper red. What are acids used for? Well, vinegar actually is an acid, and it's used for cleaning and also in, salad dressings and stuff like that. So vinegar is an acid. There are citric acids, things like the juice that's in lemons, limes, oranges. It can also be used to make sour candies, such as lemon heads and Sour Patch candies. Ascorbic acid or vitamin C is also considered to be an acid. Your body needs that acid to function. Got sulfuric acid, which is used to produce fertilizers, steel, paints, and plastics. And of course, you have battery acid, which is the type of acid that is in car batteries. We also have a hydrochloric acid, and if you remember, we used those last year to test rocks to see if they had limestone in them. So there's all different types of acids, and they're used everywhere. They're used for cleaning. They're used in fruits. They're used in your body as vitamin C, producing fertilizer, steel, paint, plastic, and of course, different types of batteries. So what is a base? A base is when you have oxygen and negative hydrogen ions put together. If you have those in a solution, it's called a base. And again, the more of those you have, the stronger the base you have. Another word you're going to hear a lot for the word base is an alkali. So if you have alkali, it also means base. And if you remember, all of our alkali metals actually were bases, we said when we studied the periodic table. Bases are substances that can accept hydrogen ions. So since this is a negative OH, if you have one of those positive hydrogen ions from the acids come in, it can accept that. And we call that neutralizing. So when those come together, we say it's neutralizing or it's made neutral. Some properties of bases. Bases tend to feel slippery. They tend to taste very bitter. They're corrosive as well, so they can eat through things. They can also conduct electricity. Think of alkaline batteries. You may have heard of those. However, bases do not react with metals. Acids do, bases don't. And guys, if you have red litmus paper or red paper, it will turn it blue. Okay? So again, they feel slippery, they taste bitter, they're corrosive, they conduct electricity, but they don't react with metals, and they turn red litmus paper blue. Examples of bases are baking soda, most soaps, oven cleaners, Drano. Those are all examples of bases or alkalis. What are bases used for? Again, bases are used for soaps, so making soap, ammonia, and other cleaning products. The OH negative ions interact very strongly with certain substances such as dirt and grease, which is why bases are excellent for making cleaning products. Chalk and oven cleaner are examples of some familiar bases. And guys, your blood is a basic solution, which means your blood is a base or an alkali. So even your blood is a base. So how do we measure acids and bases? Well, we measure them using the pH scale. This is called the pH scale. And it measures how acidic or how basic a solution is. The scale ranges from 0, which is the most acidic, the strongest acid, down to 14, which is the most basic or the strongest base or alkali. In the middle, when you get to the middle, when you have 7, 7 is neutral. It means it's not an acid, it's not a base, it's neutral. It's in the middle. It's neither one. Okay. Now, the key to reading the pH scale is not to memorize that going down is bases and going up is acids. Because if you do that, sure enough, on the Ames test or on the Cambridge test, they'll flip it on you and they'll make it go down here from 0 up to 14. Okay? So you don't want to memorize going up or down. You want to memorize that 7 is in the middle, and because it's in the middle, it's neutral. It's not an acid, not a base. So water is considered to be a 7, and it's neutral. The farther you get away from 7, the stronger your acid or your base becomes. So if you go towards 0, you get acids, and the farther you get away from 7, the more acidic it becomes. So for instance, 6 and 5 and 4 would be called weak acids because they're weak. 3, 2, 1, 0 would be called strong acids because they're strong. Milk is a weak acid. Bananas are a weak acid. Tomatoes are a weak acid. Apples are a weak acid. Things like vinegar, lemon juice, hydrochloric acid, battery acid, those are very strong acids. Then the farther you get away from 7 going towards 14, the more basic or alkali the solution becomes, the stronger it becomes. So again, here, 8, 9, 10, and even maybe 10.5 or 11, these would all be weak bases. They're considered to be weak. And then 12, 11, 12, 13, 14, these would all be strong bases. Okay? So for instance, things like your blood, baking soda, soap, those are all weak bases. They're weak. Things like ammonia, Drano, and drain cleaner, those are considered to be strong bases. Here's how I remember it. A stands for acid. B stands for base. So A for acid, B for base. Okay. A comes before the letter B in the alphabet, so A comes first. So 0 through 6, the first numbers, 0 through 6, are your acids. And again, the farther away from 7 you get, the stronger you are. And since B comes after the letter A in the alphabet, B stands for bases, then things that are after 7, 8, 9, 10, 11, 12, 13, 14, are considered to be bases. So A comes first before B, so acids come before the number 7. B comes after A in the alphabet, so bases come after the number 7. A scale, or basically if you go up 1 pH unit or down 1 pH unit, that represents a 10-fold change in the acidity or the basicness of the solution. So what that means is going from a 7 to a 6 is 10 times more powerful than a 7. A 5 is 10 times more powerful than a 6 and 100 times more powerful than a 7. A 4 is 10 times more powerful than a 5, 100 times more powerful than a 6, and 1,000 times more powerful than a 7. And it keeps going up. Same thing going down with bases. An 8 is 10 times more powerful a base than a 7. A 9 is 10 times more powerful a base than an 8 and 100 times more powerful than a 7. A 10 is 10 times more powerful than 9, and that's 100 times more powerful than 8, and it's 1,000 times more powerful than 7. So every time you go up or down 1, it represents a 10-fold change in your solution. And here's an example. If I start with a pH of 1 and I go to a pH of 2, the first solution is not twice as acidic. This is actually 10 times more acidic. And here's another example of the pH scale. This is why I tell you do not memorize going up or going down. Memorize the numbers. because this one goes left to right. Again, A comes before B in the alphabet, so acids come first. They come before the number 7. The farther away from 7 you get, the stronger they are. B comes after the letter A in the alphabet, so bases come after the number 7. And again, the farther away from 7 you get, the stronger they are. You go from 0 to 14. Here we've got things like blood plasma is a base, a weak base. Baking soda, egg whites, that's a weak base. Milk of magnesia is a little bit stronger base. Ammonia and sodium hydroxide are very strong bases. Sodium hydroxide, guys, is the stuff, it's also called lye. It's the stuff that they use to make different types of soaps. And when they make the soap, it actually is less powerful. But basically, this will burn your skin. It burns through fat and everything. Going this way, milk is a very weak acid. Tomatoes is a little stronger. Soft drinks, notice, are actually stronger acids. That's why they say soft drinks are not good for your teeth and the enamel, and they're not very good for your stomach because they're stronger acids, so they tend to eat through both the enamel on your teeth, and they can actually eat through the lining of your stomach if you have too many of them or you have, stomach issues. Your gastric acid inside your stomach is a strong acid. Vinegar is a pretty strong acid. And finally, hydrochloric acid and battery acid are both extremely strong acids. So acid-base reactions, what happens when you mix an acid and a base? Well, if you mix an acid with a base and you mix the right amount of each one, you get something called neutralization. Neutralization means that the acid neutralizes the base or vice versa, and you end up with something that's neutral. You end up with something that's not an acid and it's not a base. So again, if you mix an acid with a base, you can neutralize that solution and make it neither one. It's kind of like thinking about, okay, if you add up 0 and 14 and you take the average of the two, you get 7. So if you take an acid that's 0 and a base that's 14, and you add them together in the right amounts, you take the average, you end up with 7, you end up with something that's neutral. Same thing with 1 and 13, same thing with 2 and 12. If you add them together in the right amounts in the right way, you get something that's neutral. Now that does not mean you should start running around mixing hydrochloric acid with ammonia, okay? Because certain reactions are deadly and will hurt you. But the idea is that if you mix an acid with a base, they will neutralize each other and come out to a level 7 and be neutral, kind of like water. So mix an acid with a base, and you get something that's neutral. It has a pH of 7, 8, right around there. Here are some common acid-base reactions. If sodium chloride, each salt listed in the table can be formed by the reaction between an acid and base. So when you mix an acid and base together, the acid from sodium and the base from chlorine together, you get sodium chloride, you get table salt. Potassium iodide, potassium is the base, iodine is the acid. When you mix them, you get iodized salt. Calcium chloride, again, calcium is the base because they're alkali metals, right? Or alkali earth metals, those are bases. Chloride, if you remember, is a non-metal, which is an acid. You put those together and you get de-icers for roadways. Same thing, potassium is the base, chloride is the acid. You get salt substitutes, potassium chloride. Calcium carbonate, calcium is the base, carbon is the acid, okay? And you mix it with some oxygen and you get limestone. And finally, ammonium nitrate. If you mix ammonium or ammonia, which is a base, with nitrogen, which is an acid, you get different fertilizers and ingredients that they put into cold packs.